it is what we're doing is we're calling it a series, and hopefully, this is going to be the first one of many more to come. And I don't think we could have asked for a better start than to have with us, the man on your screen. So we have Arvid Schneider, who's joining us for this event as the, as the super user for this very first event. I think he generously agreed to do this for us, very early morning his time. So good morning again, Arvid. Hope you've had your coffee. And I think when it comes to the audience here, I guess a lot of you may not need really, to be introduced to Arvid. He's very well known in the entire community, but he's definitely one of the lead VFX artists. He's working out of Vancouver, Canada. He's worked on some of the films that all of us have enjoyed watching. And I think the best thing is that he also runs a very popular YouTube channel, and he's sharing all of his, learnings and all of his immense knowledge, with the wider community across the globe. So thanks again, Arvid, for joining us today. And, before we move on to him, I also would like to hand it over now to one of our own, very own, who I like to call the friendly neighborhood Autodesk man. So the one that you were all saying good evening to. So always ready to help the clients, in India with anything related to Autodesk. So I'd like the one and only Mr. Samit Shetty. So there you go, Samit, all yours.
Thank you so much, Rajiv. And yes, of course, thanks, Arvid, for being a part of this show. We've been desperately waiting to do something like this, a masterclass, a super user session with you. And, when I used to talk to most of our customers and say, hey, we have some YouTube videos which I want to share. And they're like, yeah, Arvid, I already know them. So, I think for them, it's going to be somebody they're very quite familiar with. They've been watching your videos day in, day out, learning, getting educated. And yes, thanks. And also, we have Krishnan with us today. Krishnan is with Autodesk, and he's the senior Arnold developer with us. And he's also, happy to be with us. He was a part of this tour from the beginning. In fact, Krishnan introduced me to Arvid, and then this is how the story started. And as we said, we will have the developers also on this call in case if you have some questions related to products or development and so on, whatever we can answer, Krishnan will be more than happy to answer them. So that's, that's how we're going to start the show today. So before I hand it over to Arvid, I just wanted to, take a tour of what are we going to do today. And we have a safe harbor statement on today's session that, hey, in case if you guys are planning to, take some decisions based on today's session, decisions on purchases or, of our tools or Arnold or whatever. If you have any questions, please feel free to reach out to any of your partners or Autodesk before taking any decisions. Updates on Arnold have been there for quite a long time, since the time we had Arnold with Autodesk, and as a part of Max and Maya, we've been regularly updating it, and not only updating it, customers all over the world have been using it as their favorite renderer. For people who don't know what Arnold is, it's the part tracing in production Pioneer 2, and scales. It can easily be scaled at any level because it does not require extraordinary hardware. It works pretty well with what we have, and it's compatible with CPU and GPU both, ships with Max and Maya at no additional cost. And hey, I would have to do this. Sorry for that. Yep, and as I said, it ships with Max and Maya as a default render, and it also works with other DCCs like third-party, like other industry softwares like Katana, Cinema 4D, and so on. So it's widely accepted by the industry. And not only that, it is not focused for a genre of output for VFX, for animation, for even for volumetrics, hair and fur. be it metal and mix of all, subsurface scattering, live actions, completely CG characters, and all these, even music albums, ad commercials. All these people have been using Arnold extensively, and now that people have been also trying to adapt Arnold for e-commerce, to achieve photorealistic output, so that they can sell the products online, which looks exactly like the original ones, and so on. And of course, we've seen a lot of architectural walkthrough design visualization customers using Arnold for something like what you can see on the screen now. Since the time we have acquired Arnold, there has been a lot of updates to and fro continuously. And as we say, Arnold updates are independent of the Max and Maya updates. So we don't have to, you don't have to, Arnold is not dependent on the updates of Max and Maya. The development team, Krishnan would agree to it, constantly keep working on it. And as and when the updates are available and it's ready to go in the market, we have the latest build updated on our website where people can download and start using it. Now, this is a list which I'm sharing it, which is not even this year's this year's list. Since August till now, we also have a couple of more releases already there in the market. Also, the big thing which we did in December 2019 is what I remember is we released the GPU version of Arnold. Before we released, we also had a beta version, because in SIGGRAPH 2018, we, in collaboration with the NVIDIA team, we announced the GPU version of Arnold. And almost for a year or more than that, we had this beta open for industry artists, people like Arvid and other industry people, to comment on it, to give feedback on it. And based on their feedback, we have developed and made the GPU reach until here. So that's something which we really are proud of. And you can see even the GPU transition has been there throughout, from version 5.3 till 6, 6.2, and so on. We have added n number of features, tools, and performance enhancements in Arnold GPU as well. So it's not like that once we have released the GPU version of Arnold, we stopped it and we are just waiting for people to use it. There has been tremendous amount of updates on the Arnold GPU as well. Now, instead of me speaking so much about Arnold and how it is used in the industry, why don't we listen from the man himself? So here is where I would like Arvid to come forward and showcase his work to the entire team and people who, like, we have almost more than 100 people, attendees, who would like to hear from Arvid himself. So Arvid, over to you.
Yeah, first of all, thank you so much for having me here on the first Super User Show. I'm quite happy to be here. And if you guys don't know me, I am working in VFX for quite some time, doing lots of, like, actually I started out with commercial stuff like vehicle renders for Audi and Volkswagen, and then I transitioned over to feature animation, doing some Tarzan animation films in Germany. And then I moved to the UK to work on my first VFX show, which was Lion King. And from there on, I did Spectre and Fantastic Beasts and all the bigger ones. And then I moved to ILM in Vancouver in Canada. And then I was here for 5 years now, doing lots of big blockbuster movies. And since a few months now, I'm working for Image Engine, working with Arnold and having lots of fun using it in big productions as well. Let me just show my windows here, and then I talk a little bit more about what I'll be talking about. Let's see. Let's do this. That should see, hopefully everyone sees now my blue little slide. It's not crashing. It's all good. I'm having issues with Zoom, unfortunately. Is that still good? Can you still hear me?
Yeah, we can hear you, but we can also see the Zoom error message on your screen. Oh, I think we lost him.
Yeah. Am I back? I'm
yeah,
not sure.
yeah.
It keeps crashing some. Okay, sorry for that. Hopefully this will be fine. So I will be discussing a few different Arnold techniques, which I use all the time. It has nothing really to do with Arnold specifically, like how the developers are using it. This is just on my experience, how I'm using Arnold, how I'm having fun with this, and about my experience, how I got to use it. So I have 3 different stages. Stage 1 will be about scene optimization with X-Gen Fur, with water droplets, with subsurface scattering, all these things. Then I'll have a scene interactivity stage where I'll be showing you how to optimize your scene so it can have really fast iterations. And then for the final one, I'll go into detail about shader creation, what you should take care of, and how you should create good shaders. And let's just dive into that.
All right, so in stage 1, I want to talk about scene optimization, and this scene is actually fairly complex because it has quite a few different elements to it. As you can see, we do have X-Gen Fur, quite a lot of that actually,
Hey,
and we do
Arvid,
have
sorry.
these big dots on the back here, are
Arvid,
raindrops.
We can't see your screen. It's still on the first slide. I think you just have to re-share your screen. Yeah.
How about now?
Perfect. Yeah.
Okay.
And we do have these big dots on the back here, are raindrops. We do have subsurface scattering all over the place, and we have our usual ones like diffuse and specular. And we do have a few area lights at the top, and we also have one big dome light, which is illuminating the environment. On the left here, you can see the render from a client, and you can see it's very nice looking. We have a nice shallow depth of field. We have all the elements in place. We can see the fur on the stem here, and we can see all over the nice details of that little ladybug. One problem is that this render takes roughly 23 minutes and 41 seconds on my machine. So it does not seem like a high number, because in production you do tend to get way higher render times. And bear in mind, this is a rather simple scene, but it just shows how much you can optimize your scenes. And the first thing what I always do when I look at scenes, or some people tell me, oh, my renders are so slow, what can I do? The first thing I do is I look at the samples. And specifically, I do look at the camera AA samples and then the corresponding indirect, diffuse, and specular passes, like transmission and subsurface scattering, because all of these combined make up your render time. On top of that, there is now adaptive sampling in Arnold, which, if not used properly, can really be a bottleneck and really take some time. This is right now enabled, and it has a maximum AA of 20 and an adaptive threshold of 15. So this essentially is very high render settings, and it essentially means that this render will not take 4 AA samples for camera A, but it will roughly take 20, which is very expensive and takes a long time. On top of that, you do have ray depth, like diffuse and specular depth. It means how often the ray bounces in your scene until it returns the color. And the higher this number goes, the more bounces you will get, and the longer your render times will be. So I've seen quite a few different render setups, and I've seen quite a few of different render times, obviously. So I've seen people go 10, 10, 10, 10, 10, and then diffuse also 10, 10, 10. And they wonder why the render is super slow. And I can tell you, you are very much oversampling your scenes, and you're just not taking the power of rendering, which you can achieve. So I want to quickly break down what is very important and how all of this works. So quite importantly, the AA samples here are your main multiplier, essentially. So camera AA will be multiplied by itself. So in this sense here, it will be 4 times 4 samples, which equals to 16 already. And then this number will be multiplied with each of its subcomponents as if they are quadratic as well. So 3 times 3, this one will be 9. And the other ones will be 9, and this one will be 16. And this one here at the bottom will be 400. So now 16 times 400 will be a very high number. So this is how many samples actually will be calculated if your adaptive threshold is at 0.015, which is quite low, which means very high render times. So when I get scenes like this, I always first check the AOVs. In this case, these AOVs here, or this render was rendered very high, so everything will be extremely clean. That's why it took so long to render. So typically what I do before I, like how I optimize scenes, I make sure that I output all the AOVs, and it's the typical ones. So you have your sheen, your specular, your SSS, and all the default ones. And importantly, to debug is CPU time and ray count, which are similar, but they give us a bit of different results, which is very interesting to see. And then what I do, I reduce my render settings, even though these are like the client's high settings. What I always do, I go 2111 on everything. I always disable adaptive sampling, and I do this. So it's one depth for each of those ray depth. And then I hit render, hit play. Let's see what we get now. So this scene did render already. Let's show the buckets, show render tiles. And if I update full scene, you will see that we get the scene rendered. It's very quick. It's not 24 minutes, but it is 8 seconds. And you can already see that, yes, we do get noise, which is totally fine. And because we have low settings, you can see that the XGen fur at the bottom here is a bit noisy. You can see that the SSS here on this little, I call them antlers, it's probably not the right word. And then you can see we have, because of depth of field, we also have quite a lot of noise. And you can check the AOVs if you scroll down through them. So that's CPU time, we'll be discussing that. You've got your diffuse direct, you can see that is even noisy. And if diffuse direct is noisy, you only can do camera AA samples, increase those. Indirect is very noisy. We don't have sheen and specular the same. Specular direct is pretty noisy, indirect is even worse. And then you have your scattering passes, and they are all pretty bad. So this already gives me some kind of clue. And if I check the ray count, you will see that if you enable your pixel information, you can see how many samples or rays were cast. And essentially this is now 9 rays. The brighter it is, the more rays will be passed on onto your renders, which will take essentially longer. That's why I said CPU time is quite similar to ray count, because the more rays you produce, the longer it will render. And you can see that the CPU time on this specific pixel took, I don't know, 4, whatever that unit is, I'm not sure, but you can just gauge or see which took the longest. And that's also a quite good indicator which shaders or which lights or whatever are very expensive. And you can see our glass or our water droplets on the back are quite heavy, and all the subsurface scattering sections are also quite heavy. All right, so the first step, what I always do, I slowly start increasing my samples. And because we have depth of field, you would probably need to raise your AA samples. So what I always do, I zoom into a region which is very out of focus. Let's say this one at the back here, and you can see the buckets came in. And let's just go from camera AA2 to 4 and see what happens. You sometimes need to update your scene for them to actually kick in. And you can already see it got a lot better. It's still noisy, but it is getting a lot better here. And we still have quite a few of noise in the antlers and still in the specular passes. So next up, what I do, I just update my subsurface scattering, because you can see now that my subsurface scattering passes are still very noisy, these ones here. So I'm cranking those up maybe to 3, and hopefully you can see this already got a lot cleaner. And we do the similar thing for diffuse and specular, because they were also quite noisy. And let's render the bottom section here. And you can see already this is cleaning up quite nicely. We still have the problem of very low depth of field. So to get clean depth of field renders, obviously you have 2 options. You can render this in compositing, or you can increase your AA samples. And for depth of field, you unfortunately need to crank up your camera AA samples. So let's say I go up to, let's say 8, and see if this gets clean now. You always need to update your full scene. And this is now getting very clean. So what happens now is if your camera A is this high, you will sometimes oversample a few parameters. So what happens if you go on high, if you use high camera A samples, you tend to go lower on the other ones, because this will now rebalance everything. All right, so now we have a 1 minute 43 seconds render, and it's improved a lot. So let's just cycle through the AOVs. We have our diffuse direct, which looks now very clean. Our diffuse indirect has a little bit of noise on the white sections here. It might be the subsurface scattering. Then we have specular direct, which is pretty good, but then we check the specular indirect and we can still see there's quite a lot of noise in here. And this is because we reduce it back to 1. So we will definitely need to adjust that back. And then SSS is very clean on 2, and the indirect is probably negligible. So all we got to now check is how can we get rid of the noise here at the bottom. So let me just select this region here and do specular of 2 and see if we can get that cleaner. And if you compare this now with 2 specular indirect samples, it's getting a lot cleaner now. So what we can do to top everything off is we can enable a denoising operation, which is quite cool to do. So you can just head over to imagers, add imager, and then you go for the denoise noise denoiser. And what this needs is you will need to restart your render, because it will add custom AOVs for the denoiser to work. And what we can test, we can now actually reduce our camera AA samples down to 2 and hit render. So now with the denoiser enabled, you can already see that our image is still a lot cleaner, and it's now down to 44 seconds for the render. We still have some artifacts here on the depth of field areas, but that's quite easy to clean up. So what I want to do now is I want to enable adaptive sampling, because we did disable this in the beginning. So if I bring it back now on, and my good settings were roughly around 8 camera AA samples. So let's just go for safety and put this to 10. So our maximum AA samples will be 10, our minimum will be 2, and the adaptive threshold will control which kind of range of samples to use. The lower this number, the more it leans towards 10, and the higher this number, it more leans towards 2. So I want to try something like 0.005 as pretty good settings, and I still have my denoiser on. And for now, I just want to run this region at the back and see how my depth of field behaves. All right, so this depth of field now, it looks very clean, and we do have denoising on. We have 2 camera AA samples and we have 10 maximum AA samples. So now let's render the full thing and see what time savings we got. With the added adaptive sampling, our overall image is a lot cleaner just because it finds where to add or more samples to clean up the noise. Our final render time is 3 minutes 39 seconds, and our original render time was 23 minutes and 41 seconds. So we are roughly 8 times faster with these render settings. And the result, there is a little bit of difference because the denoiser also helps to clean it up. But essentially, we have a very clean image and it's a lot faster. Obviously, these settings are very specific to the scene, but I wanted to show you the overall thought process of how to eliminate noise, go through the AOVs, check your render settings, and do it step by step. Things to consider are your light samples. Sometimes they are also set to high, and sometimes if your light samples are too low, meaning one, you are sometimes undersampling, which also takes longer to render. So make sure you balance your light samples as well as your AA samples. Last but not least, I really want to touch up on the Arnold Gpu. It is a very easy way to speed up your interactive render sessions and to optimize your scenes as well. So right now my scene is set up for CPU, but it's very easy to just do the switch. Head over to your render system here and go to the device selection and just change it from CPU to the GPU. You will notice that you will gray out all these parameters. The reason is the GPU works a little bit different than the CPU, and you do not have this granular control about controls. And that makes it quite easy to control because you just have camera A and you do have adaptive sampling. And obviously you do still have the ray depth because this is a different setting. So now I switched over to the GPU. Now let's just hit play and see what we get. This is now running on the GPU, and you can see it's very fast. And if I switch over to my perspective camera, you will see that if I tumble around, we get a pretty fast response time. Currently, this session is running progressively, so the steps get finer and finer and finer until you get your resulting AA samples. Typically what you want to do, you want to always work with adaptive sampling on the GPU, or you definitely need to crank up one setting. So you can go really high on the GPU. So if you do camera AA20, this will just slowly progress and get cleaner and cleaner and cleaner. And then just after a few seconds, you get a very clean and resolved image. And this is very nice to work on the GPU. You can also use adaptive sample. How this works is quite similar to on the CPU. You specify your minimum and you specify your maximum, and then it's defined by the adaptive threshold. You don't want to go too low with the minimum AA sample. So what I always do, I go down to 5 for my minimums, and then I enable adaptive sampling, and then I go pretty high on my maximum camera AA samples. Something around 60 to 80 for max is pretty good. The GPU, as I said, works a little bit different, so you need to have different values. You can start off by going on a higher adaptive threshold, maybe 0.25, and then just let's see how that works. And this is now the result after 53 seconds. You can see we still have a little bit of noise, but all you got to do now is reduce the adaptive threshold to maybe 0.05 or something, and then you will get a clean image. And you can also use imagers, denoising, all the fancy stuff can be used on top of that as well. I have now reduced the adaptive threshold to 0.05, so now let's see until the image is resolved. Using the denoiser just after a few seconds, we have a very clean and resolved image, and this is the beauty of the GPU. It's very fast if you have a good supported GPU, and you get most out of Arnold. All right, so now we will be diving into stage 2, where I will be discussing how to optimize your scenes. So you have a very fast iteration within Maya. So it's quite important, as I always say, I will say it in the stage 2 as well, that scene interaction, being able to place lights efficiently and fast is very important, because you want that kind of real-time experience to place your lights. You don't want to place a light, wait a few minutes until you see the location. So stage 2 will be now in depth about how I set up my scenes, how I change the default render settings, and yeah, how things are going. So let's dive in there. In stage 2, I want to talk about scene interactivity. It is very important to have fast iteration times and a very good interaction with your scene when you do shading, when you do lighting, when you do grooming, all sorts of tweaks. Things need to be very speedy, and you need to see your results pretty fast. So now let's hit render and see what we get. So first of all, you can see once I move out, everything gets kind of laggy as soon as the render starts. Can see also the image is not updating very fast. Everything is very slow at the beginning. So even if I change my light colors here, it takes some time for it to actually let me select them. So let's try here. And if I then change my intensity, you will see that there is some kind of delay until it picks up. And it's very annoying if things are too slow. So what I always do, I will again check my render settings, and the first gotcha is to see your AA samples here, and you can see it's total from 90 to 100, which shows me that adaptive sampling is turned on. So make sure for interactive render sessions, disable adaptive sampling, and you should already see a lot faster response time. So that is quite important. You can still see, once you see more buckets rendering and it gets for final pixel, things start to get slow again, and it's a bit bizarre. Things get laggy and stuff. You can see now my light movements are not picked up immediately, so things are not perfect just yet. What I also tend to do, I check my ray depth. 2 is probably a good value, but it's always good for fast iteration. Just lower everything to as low as needed. Because this is a skin material, you do want to have subsurface scattering, maybe not at 3, maybe 2 is fine. And then what I always do, I also reduce my diffuse and specular samples. So now let's see what we get. We still kind of get some lagging, but it feels now very fast actually. Unless you see for the final pixel rendering, it tends to get a bit laggy again. So what that tells me is that it seems like my machine is too occupied rendering pixels and is not giving too many resources to my UI. And what you can do in your Arnold render view, you have this option here to go on to render, save UI threads. And the default is, I believe, 1. And you can save up to 3 threads for UI purposes. Sometimes, depending on your machine, this is really dependent on your machine, this is enough to get a very nice, smooth UI. In my case, in my machine, because I have probably a lot more threads to spare, it still tends to go a little bit laggy. So what I do, instead of using it through this save UI threads in here, I say none up here, but then I go to my system tabs and find the option called auto detect threads. What it means on default is that it will find all the threads your CPU has and it will take all of them to render. This, if the other one is turned off to 0, 100% of the cores will go to rendering and it will be very laggy. So I can showcase this now. You can see it got even worse now. Things got really slow and sluggish. So the solution for this is to disable this checkbox, and then you can specify either how many threads you want to use to render. So you can say, oh, I just want to use 10 threads if you have that many. And if I render now, you will see that it's so fluid. It's amazing. You can move your lights and everything feels very speedy. Let's increase my light source. You will see that it essentially is like a real-time renderer now. It's very fast, right? You can see my lights move in real time essentially, and it's really a fun way to do lighting like that. If you can spare the threads, I highly recommend you do this. Obviously, there's a few different tricks to this. Go back to render settings, and you can say, like, my current build has 80 threads. I have a dual CPU machine, so that's why my renders are also fast, but it applies to the same settings for your machines. Obviously, if you have just 20 threads to spare, using 10 for rendering is pretty good because half of them are used for UI, which in most cases is a bit much. What you can also do, you can say, I want this number to be not positive, but if you enter, let's say, -10 in here, what this tells Arnold is save 10 threads, or don't use 10 threads, do whatever you want with those 10, but just don't use them. And this is the setting I use all the time. And the reason is why I do this is because sometimes you don't know how many threads you have, and you just use, okay, I want to save 2 or 3. And this setting corresponds to the one in the drop-down menu. So if I put this to -3, this is equivalent to if you put this to the value of 3, right? So if I put this to none and use 3 here, that's totally the same thing. For my machine, what I always do, I go -20 because, as I said, I do have 80 threads and I'm saving quite a lot for the UI. It's a bit weird because I have a dual CPU, like a dual CPU system. It's a bit weird that I need to use 20. I would love to just use 5 or 10 or something. But if I use lower than 20, let's say I go down to 10, you will see that my response times are again a little bit laggy. It's not the same as I showed before. It's definitely a lot better. But it will be even smoother if I go up to 20. And again, I can spare those threads, so it's nice that I can do that. And this is now a very nice and smooth. So these are the tricks I do to do fast iterations. And also what obviously helps, if you want to quickly see final pixels, you should enable denoising. And you can also obviously go a little bit lower here. And you can also make sure that you add the imagers. So if I go to denoise option here, you will now have the Arnold denoiser applied. And if you increase your variance, maybe it's 0.8, and I restart the render, that once the render is done, you get already a very high quality clean image. So it's very good to use denoising because now in 37 seconds, I already have a very clean result of my image. And again, in 20 seconds, we have our results. So these are the few things I always do for scene optimization. Make sure you have very low render settings. Don't go crazy with adaptive. Make sure this is off. And obviously, only for your final renders, you should bump up your settings and you should do an offline render and get the best out of it. But for shading, lighting, and quick iterations, these are the tricks I use all the time. And it's just such a time saver to do more iterations, more versions until your supervisor or you itself are happy with your current project.
All right, so this was my insight of stage 2, where I'm using, like as I said in the video, I use it all the time. It's very important to really optimize your scenes and also optimize your render settings if you do lighting, if you do shading, because it's just really not so much fun if you change your shader settings and it's lagging and you need to wait. So again, these are the tricks I do. I'm not sure if it's the right things to do, but that's stuff I do all the time. So now in stage 3, I'll be showing you shading setups, what you should do, what you should not be doing with shading, because I've seen a lot of shading networks and not all of them are so pretty. So let's just dive into that here.
In stage 3, I will talk about shading setups and how to layer different materials, as this is kind of a complex topic, so I'll try to be very specific and very detailed on how I approach things. First of all, it's very important to talk about the shader itself, and it consists of several different shading lobes. It starts with base, then specular, transmission, subsurface lobes, coat, sheen, emission, thin film, and these are all the ones you can apply to the AI standard surface model. Very important are base and specular. These are the settings you will use most of the time. My default shader is a neutral gray, which consists of a diffuse albedo of 0.18, which is perceived as a neutral gray to the eye. And if you have this setup, your resulting color with your correct light setup should reflect roughly the same amount of light, which is 0.18, and the numbers below should kind of display that we are in that ballpark. This is very important, and this is how I set up my shaders all the time. So how does this essentially work? So you obviously have your base material. Let's say this is my shading sphere here. And the base is essentially at the lowest level. And on top of that, you will add your specular lobe, which goes on top of the base. And this is essentially how reflective your material is. How shiny is it? Glossy like a mirror ball, or if it's more rough. And this is what you specify in the specular tab. Transmission is the light penetrating the object and passing through it, like you would see for glass or water, where the material is actually very transparent and the ray goes through it, bounces around, and then goes out the other side. This is called transmission. What is also called transmission, but in this case it's subsurface scattering, is when the ray goes into the surface, into it, bounces around all the time, and then goes out again. So this is called a subsurface effect, and this is roughly seen in very gel-like materials. You see that in human skin and all sorts of things like that. And then the coating essentially goes on top of everything again. So I showed previously you have diffused and you've got specular, and then on top of everything, you can add a clear coat layer, which is mainly seen in car paint materials, or obviously things which have been coated with a clear gloss. Then you have sheen, which is essentially a lobe which fakes very fine fiber on your surfaces, as you would see in cloth, in jeans material, in satin, or even in peach fuzz for human skin. You can see there's some kind of very thin, whitish kind of fur, which is represented as sheen, which it has different use cases. And obviously emission is light being reflected. So if I bring up emission, you will see everything starts glowing and it will emit light. Sheen, as I said, is giving us the sheen on the edges of the surface. And you can see that our Ganesha here looks like cloth, like you want to touch it and it feels very soft, velvety-like. You can obviously change the colors for that. So now it's more like a red material, which is also very velvety. And as I said, the coat goes on top, which makes it very reflective. Subsurface scattering will let you light pass through. Let's go for skin 1, and you will see that once it's resolved, you will see that it is translucent, and it's pretty cool and very fast to set up. And then obviously transmission would be glass. As I said, if you set it up right, you will get a very reflective, transparent glass object. And these are the basic materials you can set up. And obviously, if you have your base color, this will look like a plastic, for instance. So this is obviously glass, looking pretty nice. And if I disable transmission and I bring back my base, it is our gray material. Let's disable the coat And now we just have the spec. Obviously, spec off will give you a diffuse material. So a quick thing you want to do, let's say you want to set up a plastic, you go, okay, our plastic is kind of a red tone, increase the value, maybe go more saturation, and then you have that very basic plastic material. This is the very basic, very simple thing. And again, you can do all sorts. You can do like a rough plastic like this, very rough looking. And then you can decide, oh, I want it to be actually coated. Like let's say there's a clear coat glossing on top, and you do that. So now we have two specular lobes. One is the regular specular, and then you have your coating on top, which makes us look like that. So now I want to kind of replicate the typical golden statue look of the Ganesha, right? So what you want to do, it is a metallic material, so let's crank up metalness to 1, and you can see with our red material, it looks very red metallic. But we want to pick some kind of gold color scheme, something like that, maybe go a little bit more yellow and maybe a little bit brighter. And you can see that we have a rough base looking gold material. What makes this work is you need to break it up with different materials, right? So on the standard surface here, all these attributes we changed, they all have input slots for their materials. And let's say I want to add some kind of normal map. I can go AI normal, which opens me up the node AI normal map. I can plug in my color to input, and the out value would go to my normal camera. And this will add very fine details to certain parts of your character. And then we have different kind of materials. We have different bump maps. We can use this cavity map. Let's see how that looks like. So first of all, let's create a range node, which I always use because that enables me to control my input maps quite easily. So let's connect this. Let's say I want to drive the roughness, specular out, specular roughness like that. And you can now see something happened. And we've got these clear areas. And this is essentially what the cavity map does. So if I go on isolate selected, you will see that this is my cavity map. In the AI range, what I can do, I can play around with those values. I don't want them to be super bright here. So I can just say my output max, my maximum value, which the range outputs is now, let's say 0.2. And the result of that will look now completely different. And if I just render this little region at the bottom, you can then say, oh, okay, I want it to be a little bit rough, but the kneecaps essentially should be very shiny. And this is now what this is doing. And if you now add more and more and more nodes to this, let's say we want to add a procedural noise pattern. Let's say we want to use AI cell noise instead. And what I want to do, I want to multiply those two maps together. So I'm creating an AI multiply node, hooking those two things up like that. And then the out color, I'm just picking red because red is a grayscale value, and this is needed for the specular roughness. If I visualize the cell noise, this is what it looks like. Let's switch this to Woily, and we need to increase our size, maybe go on 0.1, and you get now larger specks of these circles. If I look at my multiply, you will see we get these dots. If I check the result, you will see that our character now has these dots all over her body, which is obviously a style choice if you want to do that or not. And then again, you can do all sorts of more fun things. You can, for instance, create a different material, right? So let's say I want to create a new AI standard surface like that. And as I said before, let's just create some kind of plastic. So quite easily, you can just go maybe red. Let's say this one, and we want to reduce the roughness so it's very reflective. And what you can do now quite easily, you can just use an AI mix, which allows you to mix two different materials together. So I can just use the out color of the one, plug it in shader 1, the out color of the other one in shader 2, and make sure you connect these to your original shading engine like that. And now you have a kind of a blend. The default is 50-50. And you can obviously drive the mix with any kind of map. So if I use the typical, let's say the AI checkerboard, and hook just a luminance value. So let's just pick red because that is quite easy to reach. You can now see that we have a split material. You can change your frequency, go to 10. And you can see now we have a nice pattern, and we have our plastics, and we have our gold multiplied, and we have two materials in one. And let's go down to my standard surface 2, which is the cloth. So quite easily, as I said before, let's say we want to create a satin cloth. All I got to do is pick my color. Let's say I want to have it like a very bright green. Switch over to green tones, maybe go a little bit more in saturation, maybe bump the value up. So that is our now currently looking like a plastic. So I want to have very rough material like that. And then I want to go all the way down to sheen and introduce that. And now just by doing that, you will see that the cloth has some kind of white sheen to it. Obviously, we want to pick some kind of green tone as well. And we probably want to make it a little bit more bright and less saturated to kind of get the feel of something very cloth-like. And this is just a basic introduction on how to set up shaders, how I work with them, and what makes sense in general. Things I need to quickly touch up on is settings which I use, which gives my materials a more realistic look. So for one, everything in your surroundings is always fully 100% specular. Everything is reflecting. The only thing which makes things look dull or rough or like dry looking is the micro displacement. So a very clean surface, let's say a mirror, it's clean like that. The light will hit it and it will bounce right back off like that. It's a very clean render and you will not have any brightness, very shiny. So now let's compare this to, let's say, a paper or wood or something rough like cloth. The surface is not perfectly round like this. The surface on a microscopic level looks something like this for cloth, right? It's very broken up. So if the light hits it, let's say use a different color. If the light comes in and it hits the surface, it will bounce here, it will bounce back, it will go maybe over here, and then it will go back out. And this makes your surfaces look very rough and dry looking. And wood is similar. Wood, for instance, has these cracks and they're very like broken up like that. And the light will come in and it will bounce off, bang, 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 and then go out. And you will not get a clean result. And this is modeled with like this effect I just talked about, the bouncing, is with this roughness. And the roughness is essentially the microscopic breakup of the surface. So if you want to have a dry looking material, you should never touch the specular weight. Leave that at 1 and drive it with the roughness. So the rougher you go, the less specular response will come back to the camera. And this is very important, and the same applies for weight and all these other things. So just keep that in mind. So if I set up basic materials, I always only play with roughness, or if I don't even want to touch roughness, you should use bump maps or displacement maps.
All right, so this should have given you a little bit of insight of how I work and what my philosophy about materials, especially the specular weight one is something I always talk about, because I see so many people using a weight of 0.2 or lower because they think materials are too specular. And the main reason why they are too specular is, as I said, is that they are too shiny. So just increase the roughness and you should get a way better results. In this current slide, I just want to make you aware that you can get in touch with me. You can join my Discord community, which is called the CG Lounge. I will post a link in the chat as well. It's easier to click to. You can go there. There's tons of people already. I think we are at 5,000 members already. So it's pretty cool. There's lots of talent. You can learn. You can ask questions over there. And obviously, Substance Painter and doing different things. My Zoom did crash again.
Are you back?
I think my Zoom crashed again. I'm not sure why, but it was good timing. We're almost at the end here. Let me just share my screen for one last second.
Sure.
Screen 2. Is that now the right screen? I think so.
Yep. Got it.
Okay, so I do have, as I said, my YouTube page where I do all my tutorials, and then I have through Patreon, you can get direct mentorship from me, and then the other ones are Twitter, Instagram, and my website. So that's all I have for my social media pages, and then I would say Q&A is open. If you have any questions for my slides or for what I showed you for the stages, feel free to go ahead. And if not, we also have Krishna on here, which is the Arnold dev, who is happy to help as well. So let me just stop my screen share here. Okay.
Well, Arvid, that was fantastic, and I've seen a lot of good reaction from the audience as well. So guys, if you have questions, more questions, like, I've seen a couple of questions have been, people have been putting it on the chat box. Krishnan and a couple of members from here have been already replying to them. If you have more questions, please feel free to put it on the chat box. I would just read some questions which have been already answered. Oh, there are a couple of them which are coming. So I think something which I missed in the beginning, that was, yep, I think the denoiser and EXR have been already answered by Krishnan. Arnold, for large scale environments.
So can you expand on that question, please? Because I need to know your specific use case. I would like to think Arnold does pretty well with large scale environments, and not sure if Arvid agrees with me. But the responses that we've got with most studios is that we do fairly well with large scale scenes.
I made the same experience, like especially for outdoor large scale scene. There's nothing better than Arnold. It's very fast. I know that it has a few troubles for interior stuff, but for large scale scenes, it's kind of made for that. So that's pretty good. And there's one question, if I can share some Python scripts for Arnold for Look Dev Kit. I do occasionally send a few links out on my Discord server. It's mainly just usability scripts, so like how to select everything, assign a shader. So it's very basic stuff, but feel free to reach out on the Discord for specific help. Any other questions?
So Rahul has a question. Yeah, he wants to know that GPU rendering with sequence-based denoising is supported.
Not yet. So denoising and sequences is something that we don't officially support. Well, the thing is, you can. The results are not guaranteed, because of the way the denoising works. It works better for a single image with the GPU. So that's something that we would be working on.
But it does work quite well on the CPU, right? So with temporal stability and everything, yeah, I think that's good.
Yeah, absolutely. No, this is like a GPU specific question.
Yeah. Okay.
But yeah, it definitely does work on the CPU, like I would say.
CPU. Ravi has a question. High CPU time pass similar to start. And on Lemon, we need some more clarity on this question from Ravi. Okay, let's take Jiggy's. Denoise really degrade the detail of the render blurred. I mean, the render, it seems, is blurred or something like
that. So with both of these denoises, there's a level of detail control that you have, at least on noise, right? So you can play with that. Arvid, do you have any other tips?
Yeah, I think for denoising, you should not go too low on your default render settings. So the denoiser needs definitely some kind of variant samples to get a better result. So you cannot expect to have like 211 AA samples and get a pretty pristine, clean looking image. It's not how it works. You need to give something to get more out of it. So that's why I said you should probably go for medium render settings, and then the denoiser will do its best work. Let's see. The last question, why does displacement shader disappear? I think this has nothing really to do with cat clock subdivisions. It's just important that you need to subdivide your models beforehand and then apply displacement. Otherwise, you will just get bump maps applied, because Arnold has this auto bump feature in the displacement option, which will take your input and then apply a calculated bump map on it. So it's important to subdivide properly to get actually surface displacement as well. How do you make Arnold fog? So there are a few things to do. There's one which is called volume scattering, which is modulating dust in the air. So you would see these God rays coming through windows or through clouds. There's just an easy background shader, which you can apply. It's called AI volume scattering, I believe. And then there's volume fog, which is just a fog which is raised from ground level to a specific height you define, which is like a depth pass. I think this is deprecated. I'm not 100% sure if that is still there. Krishan, do you know?
I want to say AI fog is deprecated as well, but I will need to check.
Okay.
Let me do that in the background.
Okay, it's definitely not as used because it has a few limitations. So what I would recommend, if you want to do pretty good fog, create a box where you want to see the fog and convert that to a volume. You can quite easily do that in Arnold using volume stepping. Apply an Arnold volume shader, and then you get all the best. You can get the volume scattering. You can get light interaction with the volume fog. So that's pretty cool.
There is a question of AI.
Yeah.
AI shader has some issues with the material when it goes to low version of Arnold. Yeah.
I'm not sure I follow the question though.
So I think he says that when we use the low version of Arnold, the AI shader has some issues.
Oh, well, the newer versions probably have them fixed.
Yeah.
Yeah, also from a user-based point of view, I would always say you should always try to stay up to date with Arnold updates, just because they're adding so many features and bug fixes, and you should always try to stay up to date because it just makes sense to get the best out of Arnold as well.
There's another question. Sorry.
Yeah, no, I was about to take that question from Sarfraz. So, in terms of physical lens, camera bokeh, and things like that, there's this whole suite of post-processing effects that we have added recently called imagers. There is bloom that we have added. There's there's a bunch of imagers. I keep forgetting the name. So the camera bokeh is not something that's been added yet, but there's tone mapping that you can do. There's other lens effects that you can do. There's bloom, and there's one more. Yeah, I forget the name, but I'm saying go look at the newer versions of Arnold, and there's quite a lot of post-processing that's available to you, like what you're looking for.
And then a question about what is the efficient texture format. So I can only talk about experience, and EXR is probably the industry standard, and it has lots of features for metadata as well. It supports up to 32-bit. And this is definitely the standard in the VFX industry. So I would always say use EXR, use a format, like either go for ACES or go for linear sRGB. So these are preferred color spaces. A good question is about the specular support for volumes. I think I raised that feature or that request a few times as well. Especially for ocean rendering, it would be super nice if you can have like bubbles, which are actually volumes, but they also have some reflectance on them. But that's a feature request, I guess.
Yep.
And the other question about denoise control in post, there is no such thing, I believe, that you can do that.
So, I mean, I'm trying to understand this question again. So is what Jiggy asking is to be able to take Arnold denoisers into compositing software? Okay.
I think he wants, the question is, can I control the denoising strength after render in compositing, I think is the question.
I see. Oh, yeah, no, that's not something that we've looked at right now. So everything that happens outside of Arnold is just the image. So there isn't any additional control that we're able to provide once the image is written out.
So Ravi has
an
a question.
Concept. Yeah.
So Ravi had mentioned a question which I asked him to elaborate, and he said, "Can you please explain about the AUV CPU time in Arnold?"
Me specifically, I think it's just a visualization thing. So it just tells for that pixel how long did the CPU work on it, and it just registers a time when it started, and when the pixel or the bucket finished, it just gives you that number. I'm not sure what number unit it is, as I said in the video. But you can see if it's 5 or if it's 20, you can see that it takes like 4 times longer for the other one.
So yeah, I mean, I want to say the unit is like either microseconds or nanoseconds, but it shouldn't matter because when you're looking at an image, you sort of, it's like a heat map to say where most of your CPU time was spent resolving what pixels and which was like the fastest part of your image to resolve.
Arnold color management, yes, it supports Open Color IO, and the most recent Maya version, which is I think Maya 22, ships with OCIO ACE version 2, which is supporting ACEs as well.
Any tips for render setup presets?
Yeah.
Well, I don't know enough about render setups to answer that question, unfortunately.
I don't see the question. I'm still going through color management.
Okay. Have I gone down too far?
Oh, there. Any tips for render setup presets, which setup we can use in our sequences? So render setup is obviously a Maya specific feature. And yes, you can create your own JSON file. So you can have your, obviously you need to set it up first, but you can create your character pass, your background pass, shadow passes, and you can create this and add your expressions in there. And then you can export this as a JSON file. And whenever you open up a new scene or a new sequence, you can just import that JSON file. And if your upstream departments did a good job in naming conventions and stuff like that, it will just work out of the box. It's because render setup is very name-based. You need to make sure that everything is done properly. But then it's quite easy to share those JSON files or presets with other departments, and then can just use them and get the same results.
There was one question by 0CW0 that we missed. So the question says, any plans on adding shader material overrides to stand-ins? Stand-ins help a lot for optimizing large scenes, but if I need to tweak the shader, we need to re-export and re-import the whole scenes. So there is this entire framework called operators that exist exactly to support this kind of workflow. So the operators are like things that you can use to change in your as file very late in the render process. So yeah, I'd suggest you go see what operators does, and the kind of control that you're looking for is exactly what operators are meant to do. Go ahead, Samin.
There's a request on OCIO workflows. Somebody's asked, 2 people have asked on OCIO workflows. Any idea on that, on the production pipeline?
I can speak a little to that. It's like, obviously, every company has their own pipelines and their own use cases. So there's no real, oh, you got to do this, this, and that. But essentially, the OCIO is just a standard. So you can do all sorts of things with that. It doesn't mean that OCIO is the holy grail. You can use ACEs with that. You can use other color spaces with that. So it's just a driver for your color management system. And the good thing is quite a few DCCs support OCIO. So it's compatible with different vendors. It's compatible with the client. So that is pretty cool that everything is now using or working the same way, essentially. There was one question about how to make water droplets realistic. This question is very creative. I think there's no, like, the question is like, how can I get rid of noise? And mainly if you use roughness in your specular components, this automatically transitions into the transmission, the glass, the water effect. So if you have any specular roughness, your water droplets will look like they are frozen or frosted. So it's always important to either assign a shader which has no specular roughness, or make sure that you do not have accidentally a map which causes that problems. And then if it's still noisy, you most of the time would need to raise your transmission samples to get rid of the transmission noise, essentially.
Do you want to know about Arnold Gpu on for XGen? Any idea on that?
It's pretty much the same as on the CPU. That's why I didn't really elaborate. to be quite honest, GPU, CPU, there's not much of a difference. Like they are pretty similar. There's no like pixel matching is pretty good. So I think there are a few limitations still out there on the GPU, but essentially you can expect the same results. So all you got to do is increase your camera A samples and let it cook for thin like fiber or fur.
There's a question on from Thomas on using physical camera options for level lighting. Your thoughts?
I don't understand fully the question. Like physical camera options, I'm not sure what that means, and I'm not sure what level lighting means. I guess it's for games. I don't know. And Christian has a question about documentation about nodes. I'm pretty sure that all the nodes are covered in the documentation, right?
Yeah, I would like to think so as well. If there are any gaps, please do point them out to us so we can make our documentation better. Any feedback you have is most appreciated.
Yeah, I'm checking myself quick.
Kristen, they're asking about ocean. Beram is asking for ocean surface shading coming soon. Any thoughts on that?
Right. So you what you're looking for is like a single shader that can of an ocean.
Yeah, like Minecraft.
Yeah. We can definitely take that as a feature request back to the team.
Cool.
Yeah, I think it goes hand in hand with the volume specular as well. So that because they are similar, like a spectral shading for oceans is, I think, very similar to the specular volume shading. I just checked at Arnold Docs, and it seems that all the shaders are listed there. So, maybe have a look.
About Caustic, so I can definitely say that we are hearing you loud and clear. It's something that we're currently working on. We're exploring different strategies. So we definitely hear you loud and clear that Arnold definitely need sort of Caustic support.
From an artistic standpoint, I can tell you that Caustics is pretty much never used in production. It's it has its drawbacks because it takes a longer time to resolve the pixels, or the bidirectional path tracing is definitely takes some time. So what happens, what I can speak of my experience on working on bigger shows which rendered Caustics, is we projected them. So we either rendered a little noise pattern or something, or we found some good reference and we put them into an Arnold Gpu and we projected that onto one effect some Caustics. Obviously it doesn't work if you have a wine glass and you want that specific pattern. You obviously you either could just find an image like that and project that, or that unfortunately is not so detailed with Arnold. You can have Caustics. Arnold does have Caustic, it's just they are not as crisp you would expect them to be.
Cool. I guess we've answered more or less all the questions. There might be some which we might have missed, but what we will, because it would need some more elaborate discussions and explanation. But guys, thank you so much for being here throughout the session, and we will definitely send the recording to each and every person who have attended the session. And I think Arvid will also will be posting this video on his YouTube link. And in case if you have any more questions, I have just put an email ID on the chat box. It says autodesk@arkinfo.in. Please feel free to shoot your questions, email it to us, and we'll try as much as possible to reply to your emails. And yep, Arvid, any parting news?
Just thank you for watching me and talking about my stuff, and also all the support I'm getting on my YouTube channels. I really appreciate that. And yeah, if you want to learn more, if you want to join a community, learn or get to know other artists, join the Discord server. I'll post a link one more time in the chat. And yeah, thank you everyone for watching my stuff.
Cool. So, guys, thanks again. Thank you once again. And I know it's late evening for us, but it's too early morning for Arvid. And thank you so much, Arvid, for giving us this time, early morning for you. I know, and you were awake till quite late last night. You were, connected to us, writing emails and communication and so on. So, thank you. Really appreciate that. And we would definitely love to see more of your sessions in future. And guys, if you have any thoughts, if you would like to see some more based on some specific tutorials or some specific area in Arnold, please feel free to write to us, and we'll try and as much as possible to incorporate in our upcoming sessions. So with that, I think Krishnan, thank you so much for being here. Krishnan, by the way, I forgot to mention, he's based out of UK, and he's agreed to spend some time out of his busy schedule developing Arnold with his team. So thank you so much, Krishnan, once again.
No, absolutely. The pressure is on mine. And I was telling Arvid separately that, one thing that I miss is sitting behind artists and looking at them work. So this is something that I love doing, and yeah, happy to collaborate more.
Yeah. And unfortunately, Krishnan couldn't come to India this year, but I still remember our last trip, we had managed to meet as many customers as possible here, and we've also done some road shows in different cities, which we hope to do it very soon, hopefully. So thanks once again, everyone, and even ARK, Rajiv, Tushar, Amit, all of these people have worked really hard to put this together. We had really great audience. So Rajiv.
Thank you, Samit. The pleasure is all ours. I think we definitely need to do a lot more like these. I think it's good connecting with all the artists. I totally agree with Krishnan. That's something that we all have been missing from the last few times. Even though I don't develop Arnold, but I still like to sit behind the artist and see what they create out of our tools. It's always been a passion. So yeah, definitely looking forward to more such sessions, and we'll be happy to probably continue the super user series and touch as many topics and as many usual pain points that are always coming across, and continue to make sure that the overall community gets to learn as much as possible through these super user events. So thanks everyone. Thanks again for joining us tonight.
Thanks everyone once again, and be safe. See you soon. Thanks, Arvid.
Thank you.
Thank
Bye-bye.
you. Thanks, Krishnan. Bye-bye.
Thank you, Arvid.
Thank you.